Every program you've ever used relies on arrays. The pixels on your screen, the audio samples in a song, the rows in a database, they're all arrays under the hood. In the next few minutes, we'll cover what arrays actually are, how indexing gives you instant access, the different flavors arrays come in, and how 4 major languages let you use them. An array is a contiguous block of memory holding values of the same type. Picture 5 boxes sitting side by side, that's literally how it's laid out in RAM. Each slot gets a number called an index, and indices start at 0, not 1. So in an array of 5 elements, the valid indices are 0 through 4. Here's why arrays are special: getting any element takes the same tiny amount of time, no matter how big the array is. The computer doesn't search, it computes. It takes the base address, adds the index times the element size, and jumps straight to that memory location. Want element 3? That's base plus 3 times 4 bytes. Done. This is constant time access O of 1. Not all arrays are the same. Static arrays have a fixed size set at compile time and usually live on the stack, they're fast but inflexible. Dynamic arrays live on the heap and can grow as you add elements, like vectors in C++ or lists in Python. And multi-dimensional arrays let you represent grids, matrices, or even higher dimensional data. Think of an image as a 2D array of pixels. In C++, you have 3 flavors to pick from. A raw C-style array, declared with brackets and a fixed size, gives you the lowest level access. STD array is a safer fixed-size wrapper with bounds-aware methods. An STD vector is the dynamic one. Push_back appends a new element, square brackets index, and size returns how many elements you have. Rust gives you fixed-size arrays with this syntax, the type T and the count-in baked into the type itself. Vec_T is the heap-allocated growable version. And slices, written with an ampersand and a range, let you borrow a contiguous view without copying. Ownership matters here, the slice borrows, the vec owns. Python lists look simple, but under the hood they're dynamic arrays, a resizable buffer of pointers. Append adds an element, square brackets index, slicing with a colon gives you a sublist, and len returns the count. The trade-off versus other languages: every element is a heap-allocated object, which is convenient but slower than a tight-typed array. Java keeps both worlds. Int square bracket gives you a fixed-size primitive array, fast and tight in memory. ArrayList of T is the growable, object-based version. Add appends, get retrieves by index, and size tells you how many. ArrayList holds boxed integers, not raw ints, which costs you a bit of memory and speed. Arrays are the foundation that almost every other data structure builds on. Hash tables use them as buckets. Heaps are arrays in disguise. Even strings are arrays of characters. Master arrays, and you've mastered a piece of nearly every algorithm you'll ever write. Next up, linked lists, and why they exist when arrays are already this good.